All right, folks, it's Bass Action back in action here. In our second video of the semester, we're going to look at two different concepts, and then in the next video, we're actually going to look at some concrete examples. So what we're going to do here at the top of the page is we're going to look at some geometric definitions for midpoint and segment bisector. At the bottom of the page, we're going to develop a formula for midpoint using coordinate geometry because we're going to do a lot of things with coordinate geometry in the semester. So let's start here with our top table, and we're going to start with midpoint. Now, we generally understand what a midpoint is, but let's read our definition carefully because there's a very important word in this definition. A midpoint is a point that's going to divide a segment, has to be a segment, into two congruent segments. And this word congruent is going to impact us significantly when we come over here and we write a statement. Again, these statements and reasons are going to come into play most significantly when we get into our proofs. So we want to start developing and working on these. Now, I didn't mention this in the last video because you would have only had one card to make, but I am going to go ahead and say it now, that you might want to start making some flashcards for yourself. And what you can do is on the front of the flashcard, you could, let's say, put the word midpoint, or even just put this statement right here. So on the front of a 3x5 index card, write this on the front, and then on the back of the card, you'll write the statement, the reason, and the picture that we're going to have right here. And you could do the same thing with our segment addition example that we did from the last video. You would put whatever was here under our example on the front, and then the statement and reason and our picture on the back side. All right, so let's get into this. It tells us here that I is the midpoint, and that's going to be our keyword like we highlighted between in the last video, is the midpoint of PG. So understanding our definition, if we know this definition well, which is why these are going to be important to us, we would know that if I is the midpoint of PG, this picture here would make sense. A midpoint, of course, should divide this segment PG into two congruent segments. So when we put the I on there, we want these pieces here to look like they're the same size. Now, to communicate that they're supposed to be exactly the same size, we're going to put what are called tick marks on the little pieces. And however many tick marks you put on one piece, you should put the same number on the piece that it's supposed to be congruent to. So for example, I sometimes don't like to put a single tick mark. I feel like it gets lost. So I like to use two tick marks. Well, if I want PI to be congruent to IG, and I want to indicate that if I have two tick marks here, I need to have two tick marks here. That one got put a little bit close together, so I'll redraw that there. So I'll put a second one right there. There we go. So now PI is congruent to IG visually. Now, geometrically, I can write that as a statement. Remember, this is another thing that'll go on the back side of that note card. I'm going to go ahead and I'm going to write PI is congruent to IG. Now, last time when we did segment addition and we actually wrote an equation with an equals sign, we did not put any bars on the tops of these. If we are using a congruent symbol, we want to put the bars on the top. So this statement would go with, this statement here would go with this piece of given information. And then the reason that we would write is we would write def for definition, and then we can abbreviate the word midpoint for definition of midpoint. Of course, like I said last time, you could write all those words out if you wanted. All right, segment bisector. Now, segment bisector is going to be important for you to understand. We're going to have many kinds of bisectors. We're going to have a segment bisector, an angle bisector, and a perpendicular bisector. So we do need to keep these straight. So a segment bisector can be basically any object, a line, a segment, a ray, or a plane, basically any kind of a geometric object that's going to intersect a segment at the midpoint. And again, that's a really important piece of language there. It's going to intersect at the midpoint. As it intersects at the midpoint, what we want to do is we're going to look at our picture here and indicate that. That means that this point, we learn something about it, and that point is a midpoint. So let's come over here and let's look. It's saying that M, remember this is another way we can write a line, is going to bisect US. What I often think about when I read these sentences and M bisects US is I think a knife cuts an apple. So this is what's going to be cut apart, and this is what's doing the work. So this is the bisector, and this is the object that's going to have something happen to it. So what we're going to write based on this definition is that this P is going to be the midpoint of this segment. So we can say that P is a midpoint of US, and we don't have to write the word of. Now, notice that I'm not saying that these two segments are congruent. We know these segments are congruent because this is a midpoint, but we don't know that they're congruent based on the segment bisector. It's a two-step thinking process. If you're given the segment bisector, we first identify that this is a midpoint based on this definition, and then once we've identified that, we come up here to this idea, and then we can identify the segments, the congruent segments. I know it's kind of a lot of work and students kind of resist it, but try to just let go and think in terms of those little tiny steps. Our reason that we're going to write is going to be definition of segment bisector. And again, we can abbreviate these words, but including that word segment is very important. Now, the last thing that we're going to do is we're going to develop our formula for a midpoint. On here, we're going to think of this in terms of a scenario that you already understand. Now, let's say that we have Jim who earns a 75 on his first test and a 94 on his second test. We could easily calculate Jim's average. You've been doing that for a very, very long time in your mathematical career. We all know that we're going to add these two numbers together and we're going to divide by 2, and we find that Jim's average is an 84.5. Now, if Sally earns a 90 on her first and an 80 on her second, then we can find her average as well. So we can come along and find Sally's test average. And again, you've done this so many times, you already understand this. So we're going to say our 90 plus our 80 divided by our 2 is going to be an 85. Now, what I want you to understand is that this idea of an average actually connects to what we're going to be doing later. So let's define a couple variables here. We're going to let X represent Jim's scores, and we're going to let Y represent Sally's score. So if we're thinking on our XY axis here, we're going to think of our X axis as Jim, and we're going to think of our Y axis as Sally. So we can make some ordered pairs. So their first test results, thinking X is Jim and Y is Sally, we can say is 75, 90. And their second test results are a 94, 80. And then their average would be an 84.5, 85. Now let's plot these points. So if we go ahead and we plot these points, and I've already given you a labeled grid here, we can do their first test average of 75 and 90, and we can plot that point, and there's their first. And then we can plot their second of a 94 and an 80, and I'm just kind of eyeballing them, and that's good enough for us here. And that's going to be their second. And then if we go ahead and we plot that average, that 84.5, 85, and we plot that point, what I want you to see here is that their average appears, and it is in fact the midpoint. It is the middle value of those two ordered pairs. And if you can get that in your head right now, that midpoint means average, okay? So we're going to answer this. Think midpoint means average. If you can get that in your head now, remembering these formulas will be much, much easier for you. Okay, so that's all I'm going to do on this side, on this video, and then on the next video, we're going to actually dive into some examples.